Hello my dear friends, welcome to BYJU'S Exam Prep. In this video, we'll be discussing about a very interesting segment, that is PERT analysis. Basically, this is a technique where we are calculating the estimated project completion time where we actually don't know when that activity is going to complete. So basically what we are trying to say is PERT analysis is more sort of a probabilistic approach, because here we are not knowing exact completion time of different activities. So we are using this PERT or for scheduling or for integration of different activities for the completion of the project, right? So we can say it's more sort of a blueprint of any project which is basically used for the project evaluation. Okay, so now what we have seen, that it is something related to probabilistic approach. So definitely here we won't be knowing what will be the exact completion time, right? So let us take an example. Let us suppose there is an activity which today is taking 10 minutes to complete, tomorrow it is taking 15 minutes, right? Day after tomorrow it is taking only 7 minutes. So we are not knowing the exact completion time. So whenever we are dealing with this kind of activities, we are bound to use PERT analysis, because we are not knowing the exact completion time of any activity, right? So let us try to understand this in detail, and we'll be discussing about some other parameters also which is used to define the PERT analysis. Now, already we have said that PERT basically stands for program evaluation and review technique, and it is a probabilistic approach. And being said that this is probabilistic approach, definitely we are not knowing the exact completion time of every individual activity, and the combination of different activities or the task, we call it as project. Because when the first activity will be completed, will be started, and the last activity will be completed, then we can surely say the project is being completed, right? Okay, so here let us take one example, that there is an activity whose exact completion time we don't know. Sometimes taking less time, sometimes taking more time, and on an average is taking some X time period, right? So here in PERT analysis, as we are not knowing the exact completion time, so what we do, we are defining the activity completion time under 3 time estimates. So what are these 3 time estimates? We will be seeing in later on stages, right? As we can say, PERT is a probabilistic approach, so definitely we will be using this PERT analysis in R&D sectors. Why R&D sectors? Because here we don't know the exact completion time. Okay, because research and development we are doing to such activities where we can say the project or the completion time of the activity is not certain. So here the uncertainty term will be introduced, right? So whenever there is an uncertainty term will be introduced, that means we are more or less talking about the probabilistic approach. So now let us talk about what are the 3 different time estimates in the PERT analysis, and let us see what could be the possible relation between them. Okay, so first time estimate that we need to understand is your optimistic time, right? So what is optimistic time? Optimistic time, by the name itself, we can say it's some sort of a positive one. So let us suppose if I'm trying to complete an activity, and all the condition which is being required to complete that activity is in my favorable condition. So if all the condition is in my favor, I can surely say that the completion time will be minimum. Because if all the conditions are in my favor, it will be taking the minimum possible time to complete that activity. Or I can say optimistic time is nothing but it's an estimate of minimum possible time in which the activity can complete under ideal condition, because this is not a condition which we can actually obtain in real life scenario, right? So it is the shortest possible time at which we are denoting this particular time period with TO, right? We are denoting this as TO. The second time period, the second time estimate that we need to understand is the most likely time. So by the name itself, most likely means whenever we are trying to complete this activity under normal conditions, that means some condition will be in our favor and some condition will be not be in our favor, right? So it is a normal working condition. So it is the most probable time to complete an activity. And in this case, we definitely allow some delays, which generally happens during the execution of any project. And definitely this is being denoted by TM. Okay. And the third time estimate that we need to understand is the pessimistic time. Now, pessimistic is a negative word. So we always say you should not be a pessimistic person. So pessimistic means, let's say there are 100 conditions to complete that activity and all the 100 condition is not in your favor. So whenever we are having this kind of scenario, I can say this is the pessimistic condition which is occurring with me. So try to implement that same logic in the activity. When you are completing that activity, all the condition to complete that activity is not in my favor. So that condition we call it as pessimistic time. So I can surely say the time required to complete an activity will be maximum if I'm considering this pessimistic condition, right? So it is a maximum time an activity will take. Okay, this is the maximum possible time the activity will take, because in this case I'll be taking every single condition as a delay condition or not in my favor, and this is the longest time taken, which is being denoted by TP, right? So now we have understood that we are having optimistic time, we are having most likely time, and we are having pessimistic time. And if I talk about the hierarchy, optimistic time is the least possible time and pessimistic time is the maximum time an activity will take to complete, in which includes all the delay or all the unfavorable conditions, right? So what is happening is, because this is a probabilistic approach, so can surely say all these three time estimates always follows a beta distribution curve. All these three time estimates, that is optimistic, pessimistic, and most likely, always follows a beta distribution. That means if I try to plot this in a graph, so I can simply say that the probability of completing the activity under optimistic or pessimistic will be very, very less. If I say it will be almost similar, okay, almost zero. And most likely is the maximum probable of occurrence. It will be having the maximum probability. Okay, and this is basically your beta distribution curve, right? So what we can say that because it is following a beta distribution, now we can directly take the help of mathematics, because beta curve is nothing but we are studying beta curve or normal distribution curve, we have studied, right? So I can simply say the mean value or the estimated time of completing that activity, TE, represents the estimated activity completion time. I can say it is estimated activity completion time. Activity completion time, right? Which we are denoting it as TE, and which will be equal to TP, that is pessimistic time, plus 4 time of most likely plus optimistic time divided by 6. So by using this relation, because whenever we are dealing with scheduling, we always try to or always need a single time estimate, right? But here we are dealing with 3 time estimate. That simply means that I will be converting this 3 time estimates into single time estimates by using this particular formulation. Okay, fine. And if I try to calculate this TE, we can use simply this formulation, TP plus 4 times of TM plus TO divided by 6, because it is following a beta distribution, right? Okay, so this TE, which we are calling it as expected time, it is an average time an activity will take to complete the will be taking to complete that activity, right? And we always take the all the activities will be trying to calculate this TE, which we are calculated by using this simple formulation, that is TO plus 4 times of TM plus TP divided by 6, right? So it is not only about talking about one activity. All the activities will be having 3 time estimates. Let us say there are 100 activities, so all the 100 activities will be having this 3 time estimates, and we need to use this relation to calculate the expected time of completion of an activity, and by using this, then we'll be going for the network diagram, right? Then we'll be going for the network diagram. Okay, so once we have calculated this expected time, the average time of an activity, then only we'll be able to show this in the network diagram, having the proper logical sequence either in the precedence or in the successor way. Okay, so now we have seen that, let us take one example. Let us suppose I'm having a combination of 8 activities or tasks. Okay, fine. And if I'm having all these 8 activities or tasks, right? So what will be the minimum time to complete this project? What will be the minimum time to complete this project? Let us see. Now, let us suppose if I say we are starting with task number 1. So parallelly we can start task number 1 also, 2 also, and 3 also. right? So let us suppose I'm taking task number 1 is taking 4 days, task number 4 is taking 3 days, this is taking 4 days, and this is taking 2 days. So if you try to travel in this pathway, okay, if you try to travel in this pathway, the total time taken will be 4 plus 3 plus 4 plus 2, that will be 13 days. That will be 13, right? 4 plus 3, 7 plus 4, 11 plus 2, 13, right? Let us suppose I'm not going in that pathway, I'm going by this pathway. So 2 plus 2 plus 4, that is 8 plus 2, that will be 10. And if I'm going with the third pathway, that is 3 plus 4, 7 plus 2, 9. Okay, so if I ask you the question, what is the minimum time to complete this project? Many of the students will be saying, sir, it will be 9, which is incorrect. Because, let us take one example. I can only say that when the project will be completed, if I say this is the start of the project and this is the end of the project, that means project is completed when all the activities are completed, then only I can say that project is completed, right? So let us suppose I'm taking 9 days. If I'm taking this 9 days, so in 9 days, can I surely say all the 8 tasks will be completed? My answer is no. In 9 days, I won't be able to complete all the tasks. In 9 days, only like out of 8, let us suppose 6 tasks has been completed. But in 13 days, I can surely say all the tasks will be completed. All single tasks will be completed if I say 13 days. So this 13 days will be called as the minimum time to complete this project. So minimum time to complete the project. Now I'm talking about project. Earlier, small letters we are using for activity. Capital letter will be using for project. So minimum time to complete the project, that we are doing as capital TE, that will be equal to 13 days. So in 13 days, I can surely say all the 8 activities will be completed, and once all the activities are completed, then only my project is finished. And this pathway where I am having the longest time taken or minimum time to complete the project, that pathway we call it as the critical path. That pathway we call it as the critical path. Or I can say, whenever I'm showing the critical path in the network diagram, we always try to show with a double arrow. That means I can surely say this pathway will be our critical path, right? Which we are showing with a double arrow, right? So now I can say simply that I can now remove this time. So 13 days is required to complete this all the activities, and it is the minimum time to complete the project, which I am denoting it as capital T. Okay, this is the minimum time to complete the project, right? Fine. So definitely we can have different possibilities, because this 4 days, 3 days, this time period that we are seeing on the screen, these time period, we are calculating this individual time by using this formulation TP plus 4 times of TM plus TO divided by 6. We are calculating for individual tasks. For task 1, task 2, task 3, this formulation is being applied. Okay, for saving the time, I'm already converted that, but if I'm saying PERT analysis, they will be always be giving you pessimistic, optimistic, and most likely time for all the different tasks. Then you have to use this relation to calculate the expected completion time of an activity. And once you have calculated that, then you can draw the network diagram and you can obtain this minimum time to complete the project. Okay, and this pathway from where we are getting that minimum path, we call it as a critical path, and we are using the double arrows to show in the network diagram. So once we are obtained with the minimum time to complete the project, right, that is capital TE. After that, the main calculation is coming to the picture, that is what will be the probability to calculate, or what will be the probability to complete this project in some scheduled time. Because all this, why we are doing this, we are basically doing this for scheduling, right, for the project evaluation, or to know the blueprint of the project. Okay, fine. So before actually the project is being started, we are doing this analysis. Okay, so by using this, now what we have to do, because this is a we can say a probabilistic term, so definitely we now have to talk about the project oriented, because now activity we have seen it is following a beta distribution, but here the project follows normal distribution curve. Project follows the normal distribution curve. Now, what is the normal distribution curve? Because we are dealing with normal distribution curve means we are talking about the standard normal variate. Okay, I'll be explaining you that standard normal variate also, right, in today's session. So now, because as we said that this is a probabilistic approach, so we'll be definitely talking about the variance. Now, what is variance? Variance is nothing but it is the amount of uncertainty which we are calculating, or we can say it's a measure of uncertainty. More the value of variance means more the will be the uncertainty, right? So variance is nothing but it's a measure of uncertainty of an activity of completion. Higher will be the value, the higher will be the uncertainty. And how we can calculate for an individual activity? I can simply say the variance of critical, or the variance will be equal to of any activities, not only for critical path. I will say for any activity, right? If I say variance of the activity will be equal to your TP minus TO divided by 6, right? TP minus TO divided by 6. By using this relation, we can calculate the variance for individual, for all the activities. For any activity, we can use this relation, that is the pessimistic time minus optimistic time divided by 6, right? So this is the variance of an activity. But if I want to calculate for the entire project, what will be the variance? For that, I need to identify the critical path. So critical path already we have identified by using that longest time taking path or minimum time to complete the project, right? So once we are done with the variance calculation, now what we try to do, we try to identify the variance of the critical path, we try to identify the standard deviation and the probability. Because how we can calculate this? If I say the variance along the critical paths, what we do, we try to add all the variance value only for the critical path. Let us suppose if I say in this particular example, only task 1, task 4, task 7 and task 8, these 4 tasks, that is 1, 4, 7 and 8 are lying on the critical path, right? So if these are lying on the critical path, so I'll be calculating variance for only these 4 activities, right? And I can simply say the variance of the project will be equal to summation of the variance along the critical path, right? If I want to calculate what's the variance of the project, it is nothing but only the variance along, let's say it will be variance of activity 1 plus variance of activity 4 plus variance of activity 7 plus variance of activity 8. And how we can calculate the variance? Variance for individual activity will be equal to pessimistic minus optimistic divided by 6. Okay, pessimistic minus optimistic divided by 6. So now we are quite certain that if I want to calculate what's the variance of the critical path, it is nothing but the variance of all the activities which are lying on the critical path. And once we are done with the calculation of the variance, we know that standard deviation is equal to under root of variance. This we have studied, okay? Or I can simply say variance, this is not basically variance, it is the square of that, right? TP minus TO divided by 6 whole square, that will be variance. And the standard deviation, that will be equal to root of variance, right? That is nothing but TP minus TO divided by 6. Okay, TP minus TO divided by 6. Variance definitely it is the square of that. Okay, variance is definitely the square of that. This is the variance, which is square. And the root of variance is your standard deviation. Okay, so what we have did, we have just calculated the standard deviation of the critical path. Okay, so once we have calculated the standard deviation of the critical path, let us suppose we are calculating the schedule time. Schedule time is, let us suppose you have calculated capital TE by using the critical path method, right? We have used that, identify the critical path, and it's the longest time taking, right? In the previous example, we are calculating this to be 13 days. Okay, and I'm saying that what will be the probability if I'm expecting that this project will be completed in, let us suppose 15 days. Let us take an example. What will be the probability if the scheduled time that the project needs to be completed in 15, what will be that probability? So here I'll be using the concept of standard normal variate, because this project is following a normal distribution. So I can simply calculate the standard normal variate, that we denoting it as capital Z. And what is this capital Z? Capital Z is nothing but it is the ratio of the difference between the scheduled time minus expected time divided by the standard deviation along the critical path. Or I can simply say scheduled time is equal to expected time plus Z into sigma. Right? Scheduled time is equal to expected time plus standard normal variate into the standard deviation. So let us try to understand how still we are not yet understood how we can calculate the probability, because this project follows a normal distribution and we are calculating the standard normal variate. Let us try to understand what's the meaning of the standard normal variate. It is nothing but the area of the shaded region. If I say Z equal to 0, okay, and we have seen that the relation is TS minus, or TS is equal to TE plus sigma into Z. If I put Z equal to 0, then TS and TE will be exactly same. If I try to plot this on a curve, right? If I try to plot this on a curve, let's say this is your curve, right? This is the normal variate. This is your capital TE. Okay, if I say Z equal to 0, then your TS will be located at the same location. Then the area shaded portion will be simply the 50%. So if Z is coming out to be 0, then your probability of Z equal to 0 is 50%. That means if I'm calculating what's the probability of completing this project in 13 days, then your answer will be simply 50%, because Z equal to 0. If TS and TE are same, then Z equal to 0, and for Z equal to 0, you're having this probability as 50%. Right? Similarly, if I try to calculate Z equal to 1, if I try to Z equal to 1, then I can say TS will be equal to TE plus sigma. That means this is your TE, right? This is your TS. So I can simply say the shaded portion will be slightly more than that of 50%. I can say 84% will be the probability. Right? Simply if I try to calculate for Z equal to 2, it will be 97.7, and for Z equal to 3, it will be 99.86. But sometimes we are getting negative value. Negative value means it is a mirror image of that. If I say Z equal to 3 is this one, right? This is Z equal to 3, the shaded portion. Z equal to minus 3. Probability of Z equal to minus 3 will be equal to 1 minus probability of Z equal to 3. Okay, that means it is the complementary of that. That means only the left out portion this much. Okay, here whatever being left out, the same will be calculated, that is only 0.14. You can see 1 minus 0.9986 will be simply 0.14. That is the standard normal. It's a very easy thing. If I say if I'm getting Z equal to minus 1, that means it is probability of Z equal to minus 1. It is nothing but 1 minus probability of Z equal to 1. Okay, that means 1 minus 0.84, that is near about to 16% that we are getting over here. Okay, so by just only calculating the standard normal variate, we are able to calculate the probability of completing this project, right? Okay, so this is all about the PERT analysis. I hope you all enjoyed, right? And let me quickly recap, because there are some formulation that we need to remember, right? So if I talk about activity perspective, from activity perspective, the expected completion time is your pessimistic time plus 4 times of most likely plus optimistic time divided by 6. If I say your variance of any activity, that will be equal to TP minus TO divided by 6 whole square. This is I'm talking about for activity. Right? If I say for project, let me write it over here. For project, it will be, we are calculating the value of your standard deviation, that will be simply equal to under root of summation of all the variance along the critical path. Right? And if I talk about to calculate the standard normal variate, that is equal to scheduled time minus the expected time divided by the standard deviation along the critical path. So by this relation, you can easily calculate the value of standard normal variate, and once you calculate the value of z, we can easily calculate the probability. Okay, if you're getting z equal to 3, that means the probability of completing that project will be 99.86%. That is the significance of the standard normal variate. Okay, so this is all about your PERT analysis. I hope you all enjoyed. If you want more such awesome content, please stay connected with BYJU'S Exam Prep, and I'm happily, if you're having any doubt, please try to comment in the comment section so that I can give you more such awesome videos. Okay, so thank you guys for joining with me. This is Sooraj signing off. Stay connected with BYJU'S Exam Prep. Thank you guys. Bye bye. Take care.